Assistant Professor Lujia Feng is a faculty member of the Asian School of the Environment and also a principal investigator at the Earth Observatory of Singapore. Her team studies how the Earth deforms to understand tectonics and earthquakes. She is also a co-author of a recently published review paper on the 2004 Indian Ocean earthquake and tsunami. Prof Lujia is here today to help us understand how an earthquake in our region can affect the rest of the world.
The 2004 event produced a massive tsunami that reached the oceans worldwide and triggered seismicity globally and moved enormous mass within the Earth.
I recall the news reporting that the tsunamis reached places like Indonesia, India, Madagascar, and even Chile. How can the tsunami go so far, and why did it impact different places at different degrees?
So first, the source of tsunami plays a role. For the 2004 event, the source is really long rupture, and it has a focusing effect that sends waves to certain directions. Second, the roughness of the sea floor also plays a role. Features like mid-ocean ridges and continental shelves, they can channel all the tsunami energy into some directions. Because of these, areas that are far away from the earthquake could have tsunami wave heights larger than some areas closer to the earthquake.
So Prof, the next thing that you mentioned was that a large earthquake like the 2004 event could trigger other seismic events at other parts of the world, right? Do you have an example of what was triggered and how does this happen?
When a big earthquake like the 2004 event occurs, it sends seismic waves all directions within the Earth. These seismic waves can shake up distant faults in remote locations, causing them to slip and create microseismicity. For example, the 2004 earthquake even triggered some tremors in California.
So Prof, onto the last point about Earth's movement, right? I read online that this particular earthquake made our Earth spin much faster.
This is actually a calculation from models. When a great earthquake like this one occurs, it can cause the mass movement within the Earth, including both the solid Earth and the oceans, which can in turn alter the Earth's rotation. Models show the 2004 event decreased the length of day by a few microseconds, which is really small and not noticeable in our daily life.
So Prof, I have one last thing to ask you. What is the one thing that you wish our audience can take home with them?
The 2004 Indian Ocean earthquake and tsunami created ripple effects that travel across the solid Earth, the world's oceans, and even the atmosphere. This is one good example of how the Earth system is so interconnected. Natural hazard is not one country's problem, it's a problem of all the countries. This is why all the communities like us, scientists, the media, and the public, we need to work together to get ready for the next big geohazard event.